Welcome to One Time Success, aka Diligent Tutors. Today's class is the last class in our frictional force series. In today's class, we will be dealing with system of bodies on an inclined plane. That is, we have a system such as shown. We have a system of mass M1 resting on an inclined plane and mass M2 hanging freely from the plane. Mass M1, mass what? M2. Then we have the angle of inclination of the inclined plane. The first thing we'll be dealing with is analysis of the forces acting on such system. So if we have a body of mass M1 hanging on an inclined plane, we have the force parallel to the plane, which is what? W sine theta, tending to move the body down the inclined plane. Then we will have the frictional force, which can either act upward or downward, depending on the direction of motion of the system. In this case, the frictional force is acting downward, assuming that the system is moving up the inclined plane. We have the tension on the string that connects the body of mass M1 towards M2. As usual, we have the normal reaction, which is what? W cos theta. Now, let's look at the acceleration of such system. Now, for us to calculate the acceleration of the system, we must assume direction of motion. In this case, we are assuming that the system moves up the inclined plane. Now, if the system moves up the inclined plane, we will have to analyze each of the masses separately. Now, for the body of mass M2, the body of what? Mass M2. Since the body is moving down, it means the weight is greater than the tension. So we say weight minus tension is equal to the resultant force with which the body moves. From there, we make T, the tension, the subject of the formula. We will have what? M2G minus what? M2A. Now, for the body of mass M1, since the system is moving up, the tension is greater than the force opposing the motion. Now, note that since the system is moving up, the frictional force will act down the plane, will oppose motion. So, we will have that tension, the force causing the body of mass M1 to move, minus the sum of the forces opposing the motion, which is frictional force plus mg sine theta, will give us the what? The resultant force. If we make T the subject of the formula, we have M1A, that is mass times acceleration plus frictional force plus mg sine theta as our what? Tension on that body of mass M1. Now, but we know that our frictional force for a body in an inclined plane is mu mg cos theta. Substituting that into our equation, we will have this equation 2. Now, if we equate equation 1 and 2, this is equation 1 and this is equation 2. If we equate the two equations, we will have equation 1 equals to what? Equation 2. Now, bring the acceleration together, M2A and M1A. If we bring them together, we have M1A plus M2A. Then move mu M1G1 cos theta plus M1, this is M1, M1G sine theta across the sign of equality. So we will be having this relationship. If we make acceleration the subject of the formula, we will have this relationship rather. Now, if this plane is smooth, that is, the coefficient of friction is 0, the frictional force become what? 0. So our system breaks down to m2g minus m1g sine theta over m1 plus m2. Now let us look at the second conditions. If the system moves down the inclined plane, the first condition is that if the system moves up the inclined plane. Now we are taking a condition if the system moves down the inclined plane. Now, if the system moves down the inclined plane, now for the body of mass M2, the tension is greater than the weight. That is why the body is moving up. So we have T minus W equals to M2A. Now, W is M2G, and from there we get our what? Equation 1. Now, since the system is moving down, the weight, the force parallel to the plane W sine theta is greater than the frictional force that opposes the motion and the tension. So we will have what? Mg sine theta minus T plus frictional force equals to M1A. Now, in that, if we substitute our frictional force, know that the mass here is again M1. So we have that condition, and by our relationship, this mass, take note in this condition, M here is M1. So if we make the acceleration the subject of the formula, we will have this relationship. If this plane is smooth, we'll have this as the what? Acceleration of the system. Now, let's take example. A body of mass 10 kg on a smooth inclined plane is connected over a smooth pulley to a mass of 15 kg as shown above. The acceleration of the system is, we are looking for what? The acceleration of the system. Now, let's go through that. Now, we will have to analyze that the body of mass what? The body of mass 15 kg. The body of mass what? 15 kg. Now the weight on that body is what? The weight will be 15 times 10, that is what? 150. Now, since the plane is smooth, frictional force is 0. The force that tends to move the body down the inclined plane will be the weight sine 30. The body is of mass 10 kg, so the weight will be what? 10 times 10, which is what? 100. So let's start for the 15 kg body. Let's analyze that. Now we assume that the system is moving down. So we will have 150 minus tension is equals to the resultant force, which is 15A. In this, we have 150 minus 15A is equals to T. So T is 150 minus 15A. That is equation 1. For the body of what? Of 10 kg, we have assumed that the system is moving up, so tension minus 100 times 30 will be equals to the resultant force, which is 10A. And T minus sine 30 is 0.5. 0.5 times 100, that will give us 50 equals to 10A. So T again is 10A plus 50. Now this is equation 2. Now equation 1 and equation 2 are equal because tension on the same string is equal. So we have 150 minus 15A is equals to 10A plus 50. Collect like terms. 150 minus 50 is equals to 10A plus 15A. So 150 minus 50, that is 100. 10a plus 15a, that is 25a. So a is 100 over 25, and that will be 4 meter per second square. So the acceleration of the system is 4 meter per second square. Now let's look at another example. A 2 kg mass on an inclined plane that is inclined 30 degrees to the horizontal is connected through a string over a smooth pulley to a 5 kg mass hanging freely. If the coefficient of friction between the 2 kg mass and the inclined plane is 0.2, calculate the acceleration of the system when released, and then number 2, the tension in the string. Now we don't need this and here. This is so. Let's look at that system and analyze it. Now for the body of mass 5 kg, the weight to be 5 times 10, we are using g to be 10 meter per second square. That will give us that. Again, we are assuming the whole system is moving up the inclined plane. The tension there. Then there's frictional force this time. So the normal reaction, which is W cos theta, will be what now? Will be 20 cos 30. That's what it will be. Alright, so we have our normal what? Our normal reaction R to be 20 cos 30. So our frictional force will be acting down the plane because we have assumed that the system is moving up. Now note that if you assume the system is moving up or the system is moving down, the value of your acceleration will remain the same, but the sign will change. If your assumption is correct, the acceleration will be positive, but if your assumption is wrong, the acceleration will be what? Negative, but the same value. So let's start for the 5 kg body. For the 5 kg body. So we have the system is moving down. So 50 minus tension is equals to 5A. From there, we have 50 minus 5A is equals to tension. So tension is 50 minus 5A. Let's call this equation 1. Now, for the body of 2 kg, the 2 kg body, we have T tension minus 20 sine 30 plus frictional force, which is what? Which is coefficient of friction 0.2 times normal reaction, which is 20 cos 30, and that will be equals to MA. M is 2, and so MA becomes 2A. Now look at the question very well. You see that the coefficient of friction in the question is what? Is 0.2. So if we put that together, that will be T minus, let's just put that together, 20 sine 30 plus 0.5 times 20 cos 30. That will give us 13.46 41. That will be equals to 2A. So T will be 2A plus 13.46 41. This is our equation 2. So equate equation 1 and 2. That will give me equation 1, 50 minus 5a is equals to 2a plus 13.4641. So collect like terms, 50 minus 13.4641 will be 2a plus 5a. So 50 minus 13.4641, that will give us 36.5359 equals to 7a. Divide both sides by 7, so our a will be 5.2194 meter per second square. Alright, so we've gotten the acceleration with which the system moves. Now to calculate the tension, we can use equation 1, which is tension is equals to 50 minus 5a. That will be 50 minus 5 into 5.2194. That will give me 50 minus 5 times 5.2194 will give us 26.097. If we subtract 50 minus 26.097, that will give us 23.903. So the tension on the string T is equals to approximately 24 Newton. So you can see that analyzing the system naturally is better than just applying the formulas. Knowing how to do your calculation by just analyzing the system, I prefer that to just applying the formulas, because the condition of calculation might change. So you have to lay down relevant questions and practice them for your exam. Thank you.